go, friends. Page 9. So today's proofs have vertical angles. At least these two do. Okay, so here we go. We wrote this down last class. Vertical angles are congruent, and we made a 3x5 card. So you can have vertical angles in congruent triangles. You can have vertical angles in not congruent triangles and similar triangles. And we have a given statement and we have a proof statement. So I pick up my straight edge and I'm going to draw a T-chart or whatever you want to call it. I have to have my vertical line and my horizontal line, kind of like this. I want to say that this space is a little tight, but not too bad. It's for a 4-step proof, so you can make that fit, kids? Yeah. All right. So we start off by doing that. What word goes on the left? Statements. Statements. And on the right, we get reasons. Mine's going to be a little bit squished. So, if you get excited and you want to write down the given, go ahead. What do you see how blank my picture is? How many people marked their pictures?
Oh, I already did.
Okay, so that's not enough hands. Does that make sense, everybody? I need every hand to go up when we do that part. So let's go back. It says AB bisects DC. So DC is going to get the tick marks. AB is the chopper. Does that make sense? You got to read that really carefully. So AB bisects DC. Here is DC. DM is congruent to CM. Okay? Now, what kind of marks are we going to use for this statement? Angle. Is that tick marks? They're arcs, right? Arcs. Okay, so we find angle A. And we find angle B. So now we have marks. And actually, that angle and that side are really far away from each other. However, the lesson says we have what kind of angles coming into play?
Vertical.
So we can then put double arc there. So I have two angles and a side. Is this angle, side, angle? Or angle, angle, side? Did you guys see angle, angle, side?
Yeah.
Okay, good. So we know we're headed towards angle, angle, side. Our picture's now complete, and we've done some brainstorming. Question: if we're going to prove by angle, angle, side, right now, how many congruency statements do we have?
3. Oh, wait.
One.
Right now, we just have one. Okay. We got to write 2 more statements. Is everything okay?
Yes.
At the door? Yeah. Okay, good. Let's go to number 2. What do you guys want to do next? Okay? So we can say a segment. So we'll have to do a 3x5 on this. A segment bisector divides. Now the rest of it is the same, essentially. Divides a segment into
two congruent
segments. Yeah.
All right, tell me what's the flashcard.
So now this is the side that's specific to the triangle. Should I talk about the 2 angles over here? What goes here?
We could say.
What are the segments?
DM.
Yeah, DM
Equals CM.
yeah, is congruent to CM. Very good. Okay, so when I read from left to right, it's like this is congruent to that because a segment bisector, blah, blah, blah. Okay, now we're going to, oh, this is another thing. If it helps you, do you see how I use 2 lines to write my stuff over here? I don't want to shove statement 3 up high right here and then have reason 3 lower. You guys see how that's weird? So if you need to, use your straight edge to kind of just give yourself like a little line here to be like, okay, you know what I mean? Like, so you're still kind of working. You can line, like some kids do make lines in between each step to help them see what's going on. If you do that, you don't have to necessarily number your steps. Okay, so it's just something to help you out visually. I was working with someone yesterday. We were like, I'm like, where's your other three part? And so it was just an interesting thing. Teachers will work hard to get you as many points as possible, but just realize that. So 3. That's not a thing. 3. All right. We now have our side in there. Cool. That's done. Angle and a side, whatever. We need this angle, right? Here we go. We got to name those angles. The letter in the middle is going to be M. So I can do AMC, right? And then I would do B, really, or DMB, I mean, like Dave Matthews Band.
What's that?
I was like, run. AMC is congruent to angle BMD. And this is the deal. We have to write vertical angles are congruent. And you could put vert angles are congruent. Do you see how easy it is when you start to use symbolic language? It's fun. Please. But you can always write out words. If you're the person that wants to write words because it makes more sense to you, please do that. Yes? Yes. Okay. Are we done with this proof?
No.
Essentially, yes, but no, right? Are we ready to close the deal?
Final one.
Yeah. So by angle, side, we know that triangle.
ACM.
Thank you.
Congruent to triangle BDM.
There you go. Triangle BDM.
And then for the
I would like you to.
triangle.
Well, I want you to make your table, put in the given, and mark your picture. Can you mark your picture?
Yes, I.
My picture's looking really naked. Do you guys understand the whole like bisect each other thing? Like they're going, right? They're chopping each other. So which one did you guys mark first? Okay. So if I put singles here, that's cool. Can I put singles on the other one?
No.
Do I know if LO is the same length as MP?
No.
So I want to do doubles, or like I can put doubles on one and singles on. You know what I mean? Like they're 2 different pairs. Okay, cool. Did everybody have those marks? Yeah. Did anybody put some other marks on there? What else did you put down? What'd you guys get?
The vertical angle.
Vertical angles, right? So we marked the vertical angles. So do you know your goal? What's gonna be your last statement? So this is where, friends, this is where people do the bread. They go down to the bottom of the page and they're like, I don't know the step yet, but it's going to be a triangle. LMN is congruent to triangle OMP, was it? Yeah, OPN. And they know they're going to use what? Side angle side. Now this actually could earn a point as long as you've got something in there, at least one thing in there, right, to support it. Does that make sense? If it's really naked, I don't know if this would get you a full point. And if this is not right, and that's the only way to prove the triangle. So that's the other reason. Okay, so now let's go back up. Do we have any congruency symbols in here yet? None. Okay, so let's do our vertical angles first. That's easy, right? Okay, so here we go. Angle. The letter N needs to be in the center of both. So LNM.
Is congruent to angle ONP.
Yep, ONP.
Sounds awesome.
All right. If I just write vertical angles, is that enough?
No.
No. Does everybody else know why? Vertical angles not enough? Vertical angles not enough. What vertical angles are congruent?
That's on the flashcard.
So if I just write the words vertical angles, you can't get full credit for that statement, reason, pair. And that breaks our heart. And that's probably why remember how I showed you all those guys that got zeros? They probably got zeros because they just wrote the angles and just wrote vertical angles. That's not a complete statement, reason, pair. So the deal is up here we said a segment bisector divides a segment into two congruent segments. That's still correct. We just now have two of them. We don't have to write this twice though. Okay, so this is what we do. So in step 3, we write, let's see, the first one was LN. So LN is congruent to its other half is ON, right?
Yeah.
And all you have to do is then put a comma. What's the other one? MN is congruent to PN. Do we have our 3 congruency symbols? So are we done?
Yep.
We're all done. All we have to do is label this as step 4. And like, say you actually did leave an awkward space, you could always just do something like this. You know what I mean? It's not a big deal. Like, that's not a big space, but like, say you really did put it at the bottom of your page. Okay, what time is it? It's calm yet. How many triangles do you see? Take your time. So a lot of people are putting up this number. Okay. So there are 5 triangles. What do you think is special about triangle AEC? What do you think about a triangle AEC all by itself? What kind of triangle could it be? What is its characteristic or classification?
2 scaling.
Is it scalene? Is
isosceles.
AEC scalene? Do you see the isosceles? Does it look like this might be congruent to that?
Yeah.
Okay.
But we don't
So, I know. Okay. Does anybody see a set of vertical angles? Great. Now pause. If we're going to use the vertical angles, what 2 triangles are they in? This triangle is ABE. So we would be proving ABE is congruent to triangle. What's on the other side? Yeah, I think I just put the letters in the wrong order. Doesn't matter. Now, take your first color. Triangle BAC. Outline it. Take your other color. DCA. Okay, I'm going to pull DCA out. Here is triangle. Whoa, here is triangle DCA. DCA. Here is triangle BAC. I didn't draw it quite as big as the other one. Sorry. BAC. Doesn't matter. Oh, I just put a mark in there that I shouldn't have. So friends, go back to those vertical angles. What letter has to be involved if the vertical angles are going to be part of the proof? E. Are any of our angles E?
Unfortunately not.
No. So this is one of the situations where there is vertical angles, but if I did a vertical angle statement reason pair, I would get 0 points even if I did it 100% correctly. Because it's not moving you forward in the proof. Does that make sense? It doesn't have anything to do with these two triangles. Okay. So let's pause it there. Okay. We'll finish this up next class, and that's totally cool.